Hello, folks. Good morning, good afternoon, wherever we are in the day by now. Before I proceed, I just want to acknowledge that this is your last lesson video ever. Or maybe, I don't know. For me, anyway. Whoop whoop. Alright, now that we've acknowledged that, let's keep going. This last lesson video is on something called Pascal's triangle. So here's how you make Pascal's triangle. The top number in the triangle is 1. Every row after that will start with the number 1 and end with the number 1 and have one more term in it than the row before it. So the second row is going to have just the two numbers 1 and 1. The third row, again, you start with number 1. And then to get this next term here, you add the two terms above it, which 1 plus 1 is then 2. And then you end the row with a 1 as well. So for the next row, you get 1. 1 plus 2 is 3. 2 plus 1 is also 3. And then you end the row with 1. Then you get 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then you end the row with a 1. Let's do 2 more. 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is also 10. 4 plus 1 is 5. And then end off with a 1. And then the last row we'll say is 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 6. And then end with a 1. Now, we're stopping here, but Pascal's triangle is infinitely long. You can make it, you can continue this to infinity if you'd like. So basically what this is used for is binomial expansions. So prior to this lesson, if I asked you to expand, let's do like 3a plus b to the 4th power. If I asked you to expand that, I would just be cruel, because essentially what you would probably do is 3a plus b times 3a plus b times 3a plus b times 3a plus b, and you would probably take pairs of these, do FOIL, distribute them, get your new trinomials, and then you'd have to distribute all of those 3 terms to each other, end up being 9 times. It would just be kind of crazy. So I wouldn't ask you to do that because, again, that's just being a little bit mean. So what Pascal figured out, though, was that there was a pattern to doing that binomial expansion, so that I could give you a binomial of the form x plus y to the n power, and you can use this triangle to help you expand it without having to do all of that distribution. You still have to do some simplification, but it's definitely not as intense as that would have been. So in order to use the triangle, the very, very top row, n is equal to 0. So raising it to the 0 power, you get 1. If you have a binomial raised to the 1st power, you follow the second row. Then n equals 2, n equals 3, n equals 4, n equals 5. And we've only done our triangle through n equals 6. But again, this works for any exponent that you want. So before we do a couple of examples, I want to write down some qualities about the triangle and about when you expand your binomial. So even if you're unsure of what the heck I'm talking about, just go with me for now. When you expand your binomial, the first term is always going to be x to the n power, and the last term will always equal y to the n power. Okay, next big takeaway is that the sum of the exponents for each term equals n. The sum of the exponents for each term equals n. And then the last note, from left to right, two things are true. The x exponents decrease by 1. Y exponents increase by 1. Okay, so here's how it works. We're just going to do 2 examples. Number 1, if I ask you to expand x plus y to the 4th power, the thing to note here is that my exponent is 4. So if I look at my triangle, I want to follow the row where I have n is equal to 4. And if I look at that row of numbers, the triangle is what gives us the coefficients for each term. That's what Pascal's triangle is. It's the coefficients for the terms of our binomials. So for n equals 4, I'm going to start off with the coefficients 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And then I'm going to use these notes here, these details using Pascal's triangle. So basically, again, this prevents me from having to distribute this out 4 times to all of the other binomials. If you use these as your exponents, the first term is always x to the n power, which again, x to the n, if n is equal to 4, that means this is x to the 4th power. Okay? From left to right, the exponents decrease by 1. So if my first term starts off with x to the 4th, my next term is going to decrease to x cubed, then x squared, then x to the 1st, then x to the 0. Okay, the opposite is true for the y's. The y exponents increase by 1. Okay, and I'm also going to go ahead and do the second note, which is that the sum of the exponents for each term must be n. So if my x in the first term, if x has an exponent of 4, then my y term here must have an exponent of 0, because 4 plus 0 still has to be 4. Plus 4x cubed. My y's are going to start with 0, and they're going to increase until I get to the end. So it'll be y to the 1st power plus 6x squared y to the 2nd power plus 4y to the 1st times y to the 3rd power plus 1x to the 0 times y to the 4th power, which again satisfies the first bit, which is that the last term is going to be y to the n power. Again, in this case, your exponent n is equal to 4. And then I can go ahead and simplify all of this. So 1x to the 4th, y to the 0, anything to the 0 is 1. So this first term is just going to be x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus, again, x to the 0 is 1. So 1 times 1, all that's just going to be y to the 4th power. So this is the expansion of x plus y all to the 4th power without having to distribute and multiply things over and over and over again. You use the Pascal's triangle for the coefficients, and then you follow these rules about what the exponents should be. So let's do another one. Let's do one of the examples that I gave you earlier, 3a plus b to the 3rd power. 3a plus b to the 3rd power. So if you look at the triangle, again, my exponent is 3, so I have n equals 3 because of the exponent. So if I look at the row where n is equal to 3, the coefficients are going to be 1, 3, 3, and 1. So that's how I'm going to start it off the expansion. 1, 3, 3, and 1. That part comes from the triangle. The other stuff comes from your terms raised to a particular power. So the first term is x to the n. This is where you have to be careful. In this case, x is actually 3a. and y is actually b. So when you follow the expansion, when you take, let's see, our first term is going to be to the third power. So when you take x to the third power, it's actually going to be 3a to the third power. And then that term decreases in exponent till the end. So your next term will be 3a to the second, 3a to the first, and then 3a to the 0 power. Then your second term starts at 0 and counts up. So your second term is just b. So it's going to be b to the 0 plus b to the first plus b squared plus b cubed. Now, this one's going to involve a little bit more simplification than the other one did, so you have to be careful here. For the first term, when you have 3a cubed, you have to remember, because 3a is in parentheses, I'm cubing that entire term, that's 3a times 3a times 3a. So that's actually 3 cubed times a cubed. 3 cubed times a cubed. And then we know that b to the 0 is 1, so you can leave that alone. Plus 3 times 3a squared means 3a times 3a, which is 3 squared times a squared, plus, or not plus, I'm sorry, times b to the first power is just b, plus 3 times 3a to the first, so 3a to the first is just 3a, so then 3 times 3a will be 9a b squared. 3a to the 0 power, anything to the 0 power is 1, so 1 times b cubed is just b cubed. And then we can simplify one more time. 3 cubed means 3 times 3 times 3, which is 27, a cubed, plus 3 times 3 squared, again 3 squared is 9, times 3 is also 27, a squared b, plus 9ab squared, plus b cubed. So you'll notice the triangles helps you start the expansion, but that doesn't necessarily mean that the coefficients of your final answer are going to hold those coefficients, right? The coefficients were 1, 3, 3, 1, but by the time we expanded everything, our coefficients are now 27, 27, 9, and 1. Okay, what is constant, though, are your variables. Your variables should always add to be, the exponent should always add to be 3. So a cubed, obviously that's 3. A squared b, 2 plus 1 is 3. AB squared, 1 plus 2 is 3. B cubed is 3. So let's do one more. Number 3. X plus 2y to the 6th power is equal to. Okay, so if you look at your triangle, in this case, n equals 6. So we need to go, this was the very last row that we wrote out, was when n equals 6. So the coefficients, there are 7 of them. 1, 6, 15, 20, 15, 6, 1. So make sure you leave yourself some space. This will probably take up your the entire width of your page. 1, 6, 15, 20, 15, 6, 1. And there's symmetry in the terms, by the way, if you didn't figure that out from the triangle. Okay, so these are the coefficients. And then we take our two terms, which the first term is just x, so that is what it is. But you have to remember that your second term is 2y. Okay, so we'll start with the easy one. When we plug in x, that's our first term. It starts off with the n as the exponent in this case, which is 6. And then it works its way down. So that'll be 1x to the 6th, 6x to the 5th, 15x to the 4th, 20x cubed, 15x squared, 6x to the 1st, 1x to the 0. Your second term is going to be 2y in parentheses raised to the particular power. So you started off raised to the 0, then 2y to the first power. Again, make sure you're putting your plus signs in between all of your terms as you finish them off. Then 15x to the fourth times 2y squared plus 20x cubed times 2y cubed plus 15x squared times 2y to the fourth plus 6x to the first times 2y to the fifth plus 1x to the 0 times 2y to the sixth power. So again, your first terms, your x term, starts off at 6, its exponent decreases. The other exponent starts off at 0 and increases. And then we just need to simplify this crazy madness. So for the first term, 2y to the 0 power is just 1. So 1 times x to the 6 times 1 is just x to the 6. Plus 2y to the first power is just 2y. So then I can multiply my numbers. 6 times 2 is 12. X to the fifth y. Plus 15 x to the fourth. 2y squared means 2y times 2y, or 2 squared y squared, which will be 4y squared, plus 20x cubed times 2y cubed is 2 cubed times y cubed, which is going to be 8y cubed. Let me keep these in parentheses just so you could tell the difference and where they're coming from. Okay, plus 15x squared times 2y to the fourth in parentheses is 2 to the fourth y to the fourth, which is going to be 16y to the fourth, plus 6x to the first times 2y to the fifth. 2 to the fifth is going to be 32 times y to the fifth, plus x to the 0 is 1. So this last term is just going to be 2y to the sixth. Again, that's in parentheses, so 2 to the sixth is 64, and then y to the sixth. And then if you clean it up one more time, you get x to the sixth, 12x to the fifth y, plus, when you multiply your numbers, 15 times 4 is 60, x to the fourth y squared, plus 20 times 8 is 160, x cubed y cubed, plus 15 times 16 is 240, x squared y to the fourth, plus 6 times 32 is 192, x y to the fifth, plus 64, there's no x term, y to the sixth. So this is the expansion of that crazy binomial. Could you imagine if I had asked you to actually do that by hand without Pascal's triangle? That would be a nightmare. So Pascal's triangle has implications beyond what we're going to talk about here, but I at least wanted to introduce it to you because it will probably come up later in classes beyond this one.